learners use the reaction of magnesium carbonate with excess dilute HCl to investigate the relationship between temperature and the rate of chemical reaction. So as you can see here, we've got a rate of chemical reaction with average rate of production of carbon dioxide, and the balance equation for the reaction they gave us, the results obtained are represented in the graph below. As you can see, on the x-axis we have temperature. So if we look at our graph, if we just look at it with what's happening to temperature and average rate of reaction, we can see that as you increase temperature, the average rate of reaction is increasing, as you can see. So at 40 we are having something like 0.5 grams of carbon dioxide being produced. And we have the question that says define the term rate of reaction. When you do definitions are always from the exam guideline. If you use your own definitions, chances are that you are going to get it wrong. So all your definitions must come from your exam guideline. So I'm going to open a 2017 exam guideline and go to chemistry under rates of reaction. So we're going to define the rate of reaction define reaction rate as the change in concentration of reactants or products per unit time. Now state two conditions that must be kept constant during this investigation. So in this investigation, they are investigating the relationship between temperature and rate of reaction. So what are the other things that affect rate of reaction which need to be maintained as constant here? There are so many other things that affect rates of reaction. It's also concentration. In this case, it will be the concentration of our HCl must remain constant. Otherwise, if it changes, then the experiment is not going to be fair. So the concentration must remain constant. The other thing that must also remain constant here. In fact, let's just list all the factors that affect rate of reaction. We've got the temperature, we've got concentration, right, pressure if we are dealing with gases, right, other things is surface area. In this case, surface area, that's where the state of division. So here you can mention any of these that needs to maintain, or even a catalyst, right? So you are going to say that any of these ones should remain constant. The concentration of the acid and the state of division must also remain constant for it to be a fair experiment. Now they say use the collision theory to explain the relationship shown in this graph. So the relationship we are seeing here is that as temperature increases, the rate of reaction also increases. So if they put 4 marks, my advice is try to give them 4 bullets as your answers. So in this one, I'm going to say to use the collision theory to explain this one. Just going to say an increase in temperature, pardon my shorthand, but you must write it in full. Increase in temperature means an increase in average kinetic energy. That should be your first point. So an increase in temperature will cause an increase in average kinetic energy. Now, if you increase the average kinetic energy, it means you have increased the number of collisions. So you have increased the number of collisions between the particles. You have increased the number of collisions between the particles. And by increasing the number of collisions between particles, you have now increased the number of effective collisions per unit time. Per unit time. Then you can then tell them that because of that, there is going to be an increase in the rate of reaction. So what happens when you increase temperature, you increase the average kinetic energy. This will cause an increase in the number of collisions, and if number of collisions increase, we're going to have an increase in the number of effective collisions per unit time, which will result in an increase in rate of reaction. Then the next part, they say the learners obtained the graph above using 5 grams of magnesium carbonate with an excess of HCl at 40 degrees. Then they say calculate time taken for the reaction to run to completion, 6 marks. That means a series of calculations have to be performed. But since they specified 40 degrees, that means we need to obtain some information from the graph. So if I look at this graph, let me just bring my ruler here. One can see at 40 degrees. Okay, let's try to put the ruler there and just maybe draw in red. So at 40 degrees, one can see that it corresponds to a rate of reaction. It's corresponding to the rate of reaction of 0.5. So 0.5 grams per minute of carbon dioxide will be produced. So at 40, it means 0.5 grams of carbon dioxide is produced per minute. So in order to find out how long it will take, we need to know how many grams of carbon dioxide will come from MgCO3. That requires a balanced equation. Let's look at our equation. Is it balanced? Magnesium, magnesium, 1 carbon here, 1 carbon, 3 oxygens, 1, 2, 3, 2 hydrogens here, 2 hydrogens there, 2 chlorines, 2 chlorines. So the equation is balanced, and I can get the mole ratio by saying magnesium carbonate as to carbon dioxide. The mole ratio from my equation is 1 as to 1. So 1 as to 1. Very important to show the mole ratio. So we then now calculate number of moles of magnesium carbonate, which is going to be mass over molar mass. And then we calculate it, and the mass is 5 grams over the molar mass. Magnesium is 24 plus carbon, which is 12, plus oxygen, which is 3 times 16, like that. That should give us the mass. I think I should use, let's bring in our calculator and make sure we don't make any mistakes. Okay, I'm going to use this emulator that I have here. Hopefully it's showing on this screen. I have a feeling it's not showing on the screen, but if it's not showing, you can also work it out from your side. So 5 over 24 plus 12 plus 3 times 16, and that gives us the number of moles as 0.0595 . moles, like that. That means the number of moles of carbon dioxide that will be produced is equals to 0,0595. Then we calculate the mass of the carbon dioxide, which is going to be 0,0595 mass over the molar mass, and the molar mass of carbon is, okay, that's 12 plus 32, that's 44. So we multiply the value we got. Remember, I still maintain it on my calculator by 44. That's going to give me 2,61. So 2,61 grams of carbon dioxide will be formed. So in order to calculate the rate of reaction, remember the rate in this case is the mass over the time, the mass of the carbon dioxide over the time. So the mass we know here is 2,61, and the rate that we got from our graph is 0,5 per minute. So we're going to put our 0,5 here per minute over the change in time. Then change in time will then become, just exchange these two, 2,61 divided by 0,5. Let me use my calculator. That 2,61 divided by 0,5, that gives us a time of 5,23 minutes. Okay, now we go back to our question. The molar gas volume at 40 is 1,5 liters of carbon dioxide is collected. Okay, sorry, calculate the molar gas volume at 40 if 1,5 liters of carbon dioxide is collected in a syringe. So our data which they gave us is they want us to calculate molar gas, isn't it? And then they gave us the volume as 1,5. So we've got volume at 1,5, and the other thing we have is also the number of moles, which is 0,0595. Sorry. The number of moles, which is 0,0595. So using our formulas, we know that molar volume, we know that the number of moles is equal to volume over molar volume. So we come here, we put our 0,0595 equals to the volume, which is 1,5 over the molar volume. Exchange these two. Therefore, molar volume at 40 degrees would come out as the 1,5 divided 0, so let's look at that one and use our calculator. 1,5 divided by 0,0595, which will give us 25,21. So the molar volume is 25,21 liters or cubic decimeters. Right, that sums up the whole question.